So this lecture will focus on some of the more important points in frequency distributions, and we will practice these concepts in class. So this is just to give you the basics. Okay, so frequency distributions are defined as kind of an organized tabulation of the number of scores or data located in each category on a scale of measurement. So basically with a frequency distribution, we're placing a set of scores in order from highest to lowest, and then we're grouping together individuals who have the same scores. So what this allows us to do is at a glance, we can view the entire set of scores and see whether they're generally high or low and how spread out they are. So we typically structure this information as a table or a graph. We set up categories that make up the measurement scale or make up the response options of whatever we're looking at, and then we record the frequency and number of individuals in each category. So the scores are represented in a column designated by the symbol X. As we talked about last week, X represents each individual score. And then the frequency of occurrence of each score, how many people got that score, is represented in a column designated by the symbol F. So the simplest tables place measurement categories or possible responses under the X column from highest to lowest or vice versa. And then beside each value, we place an indicator of the frequency, which is F, the number of times the score was reported, or most typically the number of people who got the score. Okay, so that gives us a table something like this, where we have X is the actual value, and F is the frequency. So we have 2 people who scored a 10, 5 people who scored a 9, 7 people who got an 8, and so on. Okay, so we can use this to calculate things like the number of scores by adding up the frequency. Or the cumulative frequency, which is how many people were at or below a given score. So you might want to know how many people scored at or above a given score. And again, this can come from the cumulative frequency. So I might ask something like how many people scored 7 or lower on a test. And so I'd want to add up how many people got a 4, 5, 6, or a 7. So if you're looking at the score or below, you're going to start at the bottom of your frequency distribution, and you can calculate the cumulative frequency for each score by adding up. So you can see we had 1 person who got a 4, so the cumulative frequency is 1. No one got a 5, so our cumulative frequency is still 1. 2 people got a 6, so now our cumulative frequency is 1 plus 2 equals 3. We've got 3 people who got a 7. So we're taking 3 plus the 3 who got a 7 is 6. So that's 6 people who scored at or below a 7. And you can see if we add up these numbers on the frequency column, that equals 6. Okay. Another thing that we can look at is the sum of the scores. So we have to remember, though, that with the frequency distribution table, we can't just add up all the X's because that wouldn't work, because we actually have 2 people who got X, right? And so if we just added we got 2 people who had 10. And so if we just added 110, we would get the wrong number. So in order to get the sum of the scores, we have to multiply X by F for each one of our X. So 2 people got a 10, so we're going to add that together. And we'll add these all up. So if you need to get the sum of X from a frequency distribution, you can either add them all up, right? So we have 2 10s. So we've got 10 plus 10, 5 people got 9s, plus 9, plus 9, plus 9, plus 9, and so on. So you can add up each individual score. Or the sum of the score also equals the product of the frequency of the scores. So the sum of X equals the sum of F of X. So when you're using a frequency distribution, you can multiply the frequency by X for each one of your X values. So this is the frequency multiplied by X for each one of our X values, and then we can add together F of X. Okay, so we've got this new column here that is F multiplied by X. Another thing you may need to do with frequency distribution is demonstrate those distributions on a graph, okay? And so in a frequency distribution graph, the x-axis will show the possible scores and the y-axis will show the frequencies. So the type of measurement, nominal, ordinal, interval, or ratio will determine whether we use a bar graph, a histogram, or a polygon. And just note that graphing is part of what's going to be required for your final project. So we'll be doing, we'll be talking a good bit about graphing. Okay, so we use a histogram for small range or different, for a small range of different interval or ratio scores. So we start with the numerical scores, or X, on the x-axis. And then we draw a bar above, so the height of the bar indicates how frequently each score happens. So we had 9 people who got 1 parking ticket. We've got 7 people who got 2 parking tickets, and it looks like we've only got 1 person who has 7 parking tickets. Okay, when you make a histogram, you need to make sure your axes are marked and labeled. You only need to include the relevant numbers. And notice that here, for interval and ratio scales, the axis, the bars are touching and they extend to the midpoint. We can't, these are discrete, right? So we can't have half a parking ticket, so they're touching. A large frequency polygon is used when there's a large range of different scores. We still have to label our axes, right? So this is the possible scores. It's here. We've got a dot centered over the number that corresponds to the frequency. We always start with 0. We've got 9 people who had 1, 7 people who had 2, and we use a line to connect them. If we have nominal or ordinal data, we use a simple frequency bar graph, which looks a lot like a histogram. There are just gaps in between because, of course, Republican to Democrat is not a continuous variable. But we can see we've got 6 people who are Republican and 8 people who are Democrats. Okay, next we're going to talk a little bit about the shapes of a frequency distribution. And so there are 3 characteristics that describe a distribution: shape, central tendency, and variability. So this will be about shape. We'll talk about central tendency and variability later in the semester. A normal or symmetrical distribution demonstrates that you can draw a vertical line through the middle of one side and make a mirror image. A skewed distribution happens when scores pile on one end of the scale or the other, and then taper off to a tail. And then we'll talk about bimodal distributions in just a moment. Okay, so the normal distribution is a symmetrical distribution where most of the scores occur around the middle, and we have fewer scores at either end. And it's kind of dispersed proportionately, and it's symmetrical. So these are the tails down here, and very few people score on either end. A skewed distribution is not symmetrical, and it has only one pronounced tail. And so we're going to talk about the difference between a positively skewed distribution and a negatively skewed distribution. And whether it's positive or negative depends on whether the tail slopes towards or away from 0. So a negative distribution happens when the very low scores have a low frequency, okay, when the tail is closer to 0. Okay, so what this means, it's kind of, the terminology is kind of confusing. With a negative skew, the tail is closer to 0, and most scores are actually on the higher end. So you'll notice that this is not symmetrical, and we've got more scores on the high end. So negative means the tail is closer to 0 or the negative numbers. A positively skewed distribution contains extremely high scores that have a low frequency. So a positive skew has a tail that's towards the higher end of the distribution. Okay, and again, the scores tend to cluster around the lower end. A bimodal distribution is a symmetrical distribution that contains two distinct higher frequency representations of the score. So you can see instead of one nice bump here, like you would see in a normal, you see 2 points where there are a lot of scores. We'll talk about it in a couple chapters, but the mode is a measure of central tendency that we'll cover later on, and it represents the score that happens most frequently. So in a bimodal distribution, there are 2 scores that happen more often than others. Okay. Next, we're going to talk about proportions and percentages. So kind of back to frequency distributions. These are other measures that can describe the distribution of scores that we can add to our frequency distribution. Okay, so the proportion is the fraction of the total group that is associated with each score. Okay, so in order to get the proportion equals the frequency of a given score divided by n, which is the total number of people in your study. The proportion is always expressed as a decimal. All right, and remember that if you need to get n is the sum of all your frequencies because n is the total number. And we'll do examples of this in class. The percentage is the proportion times 100. Okay, so you can see percent equals P, which is proportion times 100. Or another way of thinking of this is the percentage is the frequency of a given score divided by the total number of scores times 100. So the percentage is always displayed as a percent. Okay, another thing to consider is that in some cases, a data or set of scores are too large for just a simple frequency distribution to be efficient. There's too many scores in there and you're going to have a billion different rows and it's going to be confusing. And so if data cover a wide range of values, it's unreasonable to list every single score. And so, for example, if I look at grades for a particular exam and the grades range from 51% to 96%. Okay, if somebody has every single score, that's too many, it's not meaningful, it doesn't make sense. So instead, we determine, we group the scores. Okay, so in a group distribution, scores are combined to form smaller groups, and then we report the frequency, the cumulative frequency, or the percentage or the proportion for each group of scores as opposed to individual scores. So here we have ranges or categories rather than specific values that are used for X. So each group or category is called a class interval. It's important to remember when we talk about these to use upper and lower real limits. So for example, if the scores in my class range from 51 to 96, the lower real limit is actually 50.5 and the upper real limit is actually 96.5, which gives us 46 possible scores. So if we did that, a simple frequency distribution would require 46 rows, which would be way too much. So when we do a grouped frequency distribution table, it makes things much simpler. So we use 4 basic rules to determine how we're going to do this. And the goal is to have about 5 to 10 intervals. More than 10 becomes cumbersome. Less than 5 really just means you're kind of losing detail in the data. You want the width to be relatively simple, 5, 10, 20. You don't want a width to be something like 3 where it's hard to keep track of. The bottom score in each class interval should be a multiple of the interval width. So if you're going by groups of 10, you want to start at 50. You don't want to start at 42. Again, this is about simplicity. And all of your intervals need to be the same width. So that's really important. And there should be no gaps and no overlap. So any one score should belong to exactly one interval. So this is what this look like. So this is if I have an exam and scores range from 51 to 96. In this case, we can use the range of 50s, 60s, 70s, 80s, 90s. That gives us 5 categories. And you can see, so in the scores from 50 to 59, I've got 2 people got that score, 60 to 69, 3 people got that score, and so on. I can calculate the proportion here, right? So there's 20 total. I know that by adding the sum of the frequencies. So 2 people out of 20 got in the 50s, which is a proportion of 0.10 and a percentage of 10%. The other thing to know is to remember the real limits. Okay, so a score of 90 can actually be anywhere from 89.5 to 90.5. And so we just need to remember that the real limit for the range of 90 to 99 is actually 89.5 to an upper real limit of 99.5. The rank and percentile rank is the percentage of individuals in the distribution with scores at or below that value. So we've talked about the cumulative frequency, but we can also look at the cumulative percent to see which percent of individuals got at or below a given value. Okay, so again, just like with cumulative frequency, you start at the bottom of the table and add the percent of the bottom. Okay, so 5% got a score of 4, no one got a score of 5, 10% got a score of 6. So we can say that 15% of people got a score of 6 or below on this scale. Another way you could calculate it is you could do the cumulative frequency and divide by n, or the number of scores. Okay, and the final point is, again, to remember to be cognizant of the real limits of the intervals whenever you're computing cumulative frequency and cumulative percent. So each cumulative frequency is reached at the upper limit of the scale. So if we look at this cumulative frequency, for example, the cumulative frequency is 80% of 9 is 80%. What that actually means is people who 80% of people got a score of 9.5 or lower, because the upper real limit of 9 is 9.5. If we look at 7, the cumulative frequency of 7 is 30%. The upper real limit of 7 is 7.5. So what this means is 30% of people got at or below a 7.5. Okay, so I recognize that this is a confusing point, but there will be some questions that require you to remember those upper real limits. Okay. So we will do practice on this in class, but this is to give you a chance to prepare.